So this is the second sum on relative velocity method that I will be solving. We solved one earlier. It was a 4R mechanism. In this case, this is a 1, 2, 3, 3R, 1P mechanism. Okay. So the first step, as always, is to write down the given data. And the first step, write down given data. And second step is to write down what we have to find. Okay, so this is the given data, that length of OB is 0.5 meter, length BP is 2 meter and length PE is 1.5 meter. OB is rotating with an RPM of 180. Okay, so the things that we have to find is what is the velocity of piston P, what is the angular velocity of this connecting rod BP, and what is the velocity of point E. Okay, so these are the three things we have to find: velocity of point P, angular velocity of connecting rod, that is omega BP, and velocity of point E. Okay, so we have to find this. Now as we are solving this by relative velocity method, the first step in relative velocity method is to draw this space diagram on our A3 sheet. So we have to draw this space diagram on our A3 sheet. As you can see, this is 2 meter, this is somewhat like 0.5 meter with 45 degree. Okay, so the entire length is approximately less than 2.5 meter. We have to select a scale such that this entire thing should be not more than 12 to 13 centimeter, right? So we can do a thing. See, this total length is approximately 2.5 meter. It is less than 2.5 meter. So we can say that 1 centimeter is equal to 0.2 meter. So by using this scale, what we are going to get is, for 12 centimeter, it will be 2.4 meter. So this satisfies our condition. Okay, so our scale will be 1 centimeter is equal to 0.2 meter. This scale has to be determined by you. Remember, once again, I will repeat that your space diagram should come in just this much area. Okay, so we will start off with the space diagram. Space diagram is nothing but this same diagram, this same question drawn perfectly on your A3 sheet. Okay, so whenever drawing your space diagram, first you have to write the scale. 1 centimeter is equal to 0.2 meter on both axes. And what is this a scale for? This is a scale for space diagram. Because we also have to draw a velocity diagram, the scale for the velocity diagram might be different. Okay, so we'll start off with this point. Okay, let this be the point O. What do we know? There is a link OB which is of 0.5 meter and it is at an angle of 45 degree. So we know length OB is equal to 0.5 meter, which from our scale will be equal to 2.5 centimeter at an angle of 45 degree. So let us draw that. Okay, so this will be my horizontal axis. Then I have to mark 45 degree from here. So I will take this, mark 45 degree. Okay. Join this lightly with a pencil. Now this length has to be 2.5 centimeter. So I am marking it with a pen. Please mark it with a pencil in the exam. I am just marking it with a pen so that you are able to see in the video. Okay. So I have marked 2.5 meter. This becomes OB. Now I have to draw another link which will be BP. BP is a length of 2 meters. Okay. And P is on this horizontal axis. So length BP is equal to 2 meters. Now from this scale, 0.2 meter is 1 centimeter. So 2 meter will be 10 centimeter. So taking my rounder, and scale. We can mark 10 centimeter. So this is 10 centimeter. From B, let us mark 10 centimeter. Okay. So this point becomes our P. This is point P. There is a slider over here, sliding in these guide rails. Okay. So from B to P. This is the next link. Okay. So this is our link P, slider. Okay. So what are the links? First is the ground link. This is our second link. This is our third link. And slider is our fourth link. Okay. Slider is our fourth link. So this is what we have drawn is the space diagram. Now what do we know? Based on the question, what have they given us in the question? That the crank means OB. OB is your crank. Crank makes 180 RPM in the clockwise direction. Means the crank is rotating in this direction. As O is fixed, when the crank is rotating, B is performing pure rotational motion about point O. So the velocity of B will be in this direction. The velocity of B will be perpendicular to link OB. Okay. So the velocity of B will be perpendicular to link OB. But what will be the magnitude of the velocity of B? Well, to find the magnitude of velocity of B, we can use the formula V is equal to R omega. Because the link OB is performing pure rotation about the point O. Hence we can use the formula V is equal to R omega. Okay. So velocity of B with respect to O is equal to length of OB into angular velocity of link OB. Okay. So what is the length of OB? It is given to us 0.5 meter. What is the angular velocity of OB? We do not have that value directly, but we do have the RPM of link OB. So using omega is equal to 2 pi n upon 60. Using this formula, we can find angular velocity of OB. So this will be into 2 pi n is 180. 180 upon 60. So putting it in our calculator, we will get 60. We are getting 3 pi. That is 9.425 meter per second. 9.425 meter per second. This is the velocity of B with respect to O. In what direction? This velocity is perpendicular to link OB. In this direction. Okay. So it is perpendicular to link OB. I hope by now you know why it is perpendicular to link OB. I have explained it in the relative velocity video. So please refer to that video for why it should be perpendicular. Okay. So this should be the direction. Okay, I am marking it with a red pen. In exam, you just have to mark it with a light pencil. No pen is required in the exam. Okay. So this is the direction of velocity of B with respect to O. Now I have to draw this same below. I have to draw the velocity diagram. But before I draw the velocity diagram, I have to decide the scale for the velocity diagram. Okay. So when I have to decide the scale for the velocity diagram, I first have to take a look at what is my velocity. Okay. See over here, what is the velocity? 9.425 meter per second. So I can do one thing. I can take this as approximately 9 centimeter. So 1 centimeter becomes 1 meter per second. Okay. Scale is completely up to you. You have to take it so that it is quite understandable and not too big. Okay. So 1 centimeter becomes 1 meter per second. Okay. So whenever you start drawing your velocity diagram, the first thing is to start off with a fixed point. Okay. So let this be our fixed point. Okay. So in the space diagram, whichever points are connected to ground are written over here. In this page diagram, see, only O is connected to ground, B is not connected to ground, P is not connected to ground, P is connected to slider. Okay, so only O is connected to ground. So this becomes my fixed point. Where is the velocity of B with respect to O? In this direction. And what is its magnitude? 9.425 meter per second. Okay, so based on that, I will take my roller scale, keep it parallel to the velocity of B with respect to O. Drag it downwards till I find the O point and then draw a light line. Now the length should be 9 centimeter. As you can see, it is now going to cut over there. Let me see if it is cutting. Yes, it is going to cut this. So I cannot draw it over here. I cannot draw it over here. Ideally in exam, this will also be with a pencil. So it will rub off. So what do you have to do? You have to draw the velocity diagram somewhere else. Or you have to reduce the scale. In this case, I have decided to reduce the scale because I cannot rub my point. I have decided to change my scale from 1 centimeter is equal to 2 meter per second. Okay. You can always change the scale later on if there are some problems on this, on your drawing sheet. Okay. So now what becomes? My velocity of B with respect to O is 9.4 meter per second. Therefore, because of my scale, it becomes 4.7 centimeter. Okay. So I will take this because velocity of B with respect to O is in this direction. Okay. And what is the length? 4.7 centimeter. Okay. Marking this velocity. You have to do all this with a pencil. I am doing it with a pen for visibility sake. Okay. So this becomes my small b. Okay. This is velocity of B with respect to O. Okay. So I know the velocity of B. Now I have to find the velocity of this point P. Now because this point P is on the slider, see, the slider is going to move only in the horizontal direction. So whatever you do, the velocity of P will always be in the horizontal direction only with respect to ground. So in our velocity diagram, the velocity of P will be in this direction, right? So we can draw a line parallel to this horizontal line on our velocity diagram. Why? Because P can only move in the horizontal direction. Hence its velocity will also be in the horizontal direction itself, right? This is where its velocity will be. Okay. So we know that P lies somewhere on this point, but where exactly we are still not sure. For that, what we can do? We can consider the link BP. Now considering the link BP, we can find the velocity of P with respect to B. We have to find the velocity of P with respect to B. Okay. So whenever you have to find the velocity of one point with respect to another point, what you have to do? You have to fix the second point and assume that the first point is rotating about that second point. All this has been covered in my relative velocity, introduction to relative velocity video. Okay. So in this case, the velocity of P will be perpendicular to the link BP. Velocity of point P with respect to B will be perpendicular to link BP. Okay. So we will draw it over here. This will be the direction of velocity of P with respect to B. Okay. Now I don't know in which, whether it is going to go up or whether it is going to go down. I don't know. So I can draw it like this also. Okay. Not with a pen but with a pencil. So it can be in either direction. I don't know. I just know that it is perpendicular to link BP. Okay. So we have to draw this same on our velocity diagram. So take your parallel scale, keep it parallel to link BP. So it is velocity of P with respect to B. So move this till you reach the point B. From B, draw the same line. It will cut this line over here. See, we knew P will be on this axis with respect to ground. We knew P will be on this axis with respect to B. So where both these connect, both these cross each other, this is our point P. Okay, this is our point P. So this becomes my velocity of P with respect to B, and this becomes my velocity of P with respect to O. Okay, so with this I have completed my velocity diagram, right? So what are the things that they are asking me to find out? They are asking me to find out three things. First we will look at the first two. What is the velocity of P? Well, it is very easy to find out what the velocity of P is. See, velocity of P with respect to O. O is what? Ground. So that will be the absolute velocity. So velocity of P with respect to O is the velocity of P with respect to ground. So we will measure this. This is how much? This is 3.8 centimeter. Okay. 3.8 centimeter into 2, because 1 centimeter is equal to 2 meter per second. So 3.8 centimeter will be 7.6 meter per second. So we can write it like this. Velocity of P from diagram is equal to 7.6 meter per second. Right? Next thing they have asked us is to find angular velocity of connecting rod, that is omega BP. Angular velocity of this connecting rod, BP. There is a formula that we know. Velocity of P with respect to B is equal to length of BP into angular velocity of BP. Okay. This is an advanced version of V is equal to R omega. We are just using the symbols. It is same as V is equal to R omega, nothing else. Okay. So velocity of P with respect to B is length of BP into angular velocity BP. Okay. So angular velocity BP becomes velocity of P with respect to B upon length of BP. What is velocity of P with respect to B? We can find it out from this graph. This is velocity of P with respect to B. We can find out the distance. It is coming out to be 3.5, approximately 3.4 and 3.5. So we will take 3.5. So 3.5 centimeter into 2, that will be 7 meter per second. That is 7 meter per second. Velocity BP is 7 meter per second. What is length of BP? Well, we can go over here. It is 2 meter. So what will be the angular velocity of BP? It will be 3.5 radians per second. Okay. So we have found out these two. Now the last thing that we have to find out is the velocity of point E. Okay. So see, where is E lying? Okay. We will look at the space diagram. This is my B. This is my P. This entire length is 2 meter. And they have told me that PE is 1.5 meter. Okay. So 1.5 meter. Length PE is equal to 1.5 meter. So 1.5 meter becomes 7.5 centimeter. So it is at a distance of 7.5 centimeter from here. Okay. So this becomes my point E. This becomes my point E. Okay. Now for a minute, imagine that this link BP is fixed at B. If this is fixed at B, what is going to happen? P is going to perform uniform rotational motion about B. It is going to perform uniform rotational motion about P, right? when it is rotating about the point B, see, if the velocity of P is given by V is equal to R omega, this is BP into omega. What will be the velocity at point E? It will be length BE into omega. It will be length BE into omega. So we can, using this logic, we can write down like this. Okay, see what we can write down. Velocity of P with respect to B is equal to length BP into omega BP. We can also write velocity of E with respect to B. Velocity of E with respect to B is equal to length of BE into omega BE. But see, in this, BE and BP are on the same link. If they are on the same link, they will have the same angular velocity. Their angular velocity will be the same. What does that mean? Omega BP will be equal to omega BE, because they are on the same link, and the same link can have only one angular velocity. Therefore, omega BP is equal to omega BE. Using this logic, we can write these two equations like this. First equation can be written as omega BP is equal to VPB upon length BP. Similarly, we can write omega BE is equal to VEB upon length BE. But as we know, omega BP is equal to omega BE. So, VPB upon length BP is equal to VEB upon length BE. Now, VEB upon VPB, taking this over here and this over here, will be length of BE upon length of BP. What does this mean? See, they are directly proportional to each other. EB, BE, PB, BP. Okay, they are directly proportional to each other. Means if this total length is BP, then this will be BE, and the ratio of velocities will be same as the ratio of the lengths. What is the ratio of lengths? Length BE is 0.5 and length BP is 2 meter. So this ratio, velocity of EB to velocity of PB, will also be in the same ratio. So if we know the velocity of PB, we can find out the velocity of EB. Okay, velocity of EB will be 0.5 upon 2 into velocity of PB. And we know the velocity of PB. Velocity of PB, we already know 7. Velocity of PB is 7 meter per second. So this is 0.5 upon 2 into 7, which is 7 by 4 is equal to 1.75 meter per second. So this is velocity of point E with respect to B. Okay, this is velocity of E with respect to point B. But this is not the absolute velocity of E. We want to find the absolute velocity of E. That is velocity of E with respect to ground. That is velocity of E with respect to O. So we will first mark this on the page. We will first mark this on the velocity diagram. And then we can connect O to E and find the absolute velocity of E. So what do we know? Velocity of E with respect to B is how much? 1.75 meter per second. Okay. And velocity of E with respect to B is 1.75 meter per second. Okay. Using this scale, it will be approximately 8 mm. Okay. We will use the calculator. 1.75 divided by 2. It is 0.875 centimeter. Over here, this is my point E. And what is the velocity of E with respect to O? This. Velocity of E with respect to ground is OE. Okay, so what is the length of OE? Length of OE is 4.3 centimeter. Length OE, velocity of E with respect to O is equal to 4.3 centimeter. Using this scale, it becomes 8.6 meter per second. So velocity of E with respect to O is 8.6 meter per second. That becomes our final answer. Okay, so this is quite a long method, so you have to pay attention. If you like, you can please revise this once again. Thank you.